Postgres.
Hello? Testing.
So I can click on anywhere in the
Okay. So is it hooked up to here too? And can you? Okay, I'll assume. Just raise your hand in the back if I'm too quiet or something. Okay, so you got your standard LAMP stack. You've running on Linux. You got your database, which is mainly what this talk is going to focus on. And then you got something serving requests. You choose a language, PHP, Python, Perl, Java, whatever. And then you write your application. Going with PHP here because I like PHP. And so you got a whole bunch of choices for this database layer. If you're working on Windows or you're working for a corporation, you might be using MySQL Server. If you have a lot of money, you might be using Oracle. Given that you're here tonight, you probably have used or are using MySQL. We're not really sure what's going to happen with MySQL, but I mean it's a fantastic database, and you know it's powering most of the web. So hopefully it'll be all right and keep going. And world's most popular open source database, which Postgres took, and another choice, and made it the world's most advanced open source database as their catchphrase. Not that they're competitive or anything. So, I mean, looking at these options, you know, there's a lot of differences here. You've got expensive options and closed source options, which are closely correlated, and open source options and free options, which are closely correlated. But, I mean, underneath all this stuff, and I mean, their front ends are a little different, but basically you're using SQL. They're basically all relational databases. They basically all have this structure. You've got databases, all the databases contain tables, all the tables contain rows. And if you ask someone, what is a database, most developers are going to say this because these have been so popular for so long that this is basically the only thing that people think of when they think of databases. But really, it could store anything. So I'm hoping in this talk to like introduce you to one that isn't quite structured like this, although actually Mongo is quite similarly structured to this, but it's a little different. So take some getting used to. But moving back to our relational databases, you've also got, on top of this, for each table, you have a schema for it. You predefine the schema. It's got a bunch of rows, a bunch of columns that you predefine with types, and that's nice because you know what's going into your table. And then you break up your data. You know, you make it go across a bunch of tables so that you can join it in different ways and future-proof it, so if people want to do different types of queries in the future, you got nicely partitioned data to do that with. And then you've also got this notion of a transaction, where you know if something you do a sequence of steps, and if it's successful, they all happen. Or if it's not successful, one of them failed, all of them failed. You just roll it back. It's like nothing happened. So that's a nice safety net. So, but the problem is, unless you're an accountant, you're probably not really thinking of your data in rows. Data today is kind of a mess. It's not really a row. If you look at data we use, it's an object. It's blobs of binary data. It's user-defined fields. It's these tiny little things and huge things and fields of different sizes. And it's like most programmers think of their data as these objects. And they're using scripting languages so they can just randomly add fields to these objects. And so people have come up with this way of mapping these objects onto rows, which are ORMs. Which is sort of like, it just sort of shoehorns this complex, interesting thing into this simple, basic row with very little expressive power. And it's like, it's slow, and if you need to optimize it, you're probably going to drop back into MySQL and stop using the ORM for parts of it, and it's just kind of a mess. So MongoDB is trying to solve this problem by making it easy. Making it easy to learn, easy to use, easy to map your data structure right into the database and get it right back out again without like smushing it all around. We're also trying to make something that's fast. You know, there are all these protections, you know, with transactions and the schema thing that MySQL gives you that we just kind of threw out the window. We decided to try to make it almost as fast as memcached, but persistent. And And we tried to keep the power of relational databases because you guys have all these awesome features. You can generate reports, do these interesting queries on the fly. You have query optimizers and all sorts of cool stuff. So we tried to keep all the cool features, make it really fast, make it easy to use, and we tried to make it easy to scale too. So MongoDB is easy. We tried to make it especially easy for you MySQL people. Actually, so that's nice. But if you go to mongodb.org, we've got all the binaries pre-compiled for all of your most of the major systems. So you just download the binary and you run it. We figured we don't want to put extra burden on you installing it and trying it out. So if you have MySQL, you start the MySQL server with MySQLD. That's just the process that you run. Well, you probably use like an initd script, but you know, if you dug down into it, it would eventually be MySQLD. So for Mongo, to start the Mongo server, you run MongoDB. For MySQL, you start the shell by typing MySQL, and surprise, for Mongo, you start the shell by typing Mongo. So I mean, we threw in a bunch of like shell candy too to just make it familiar to the MySQL people. I'll go over some of that in a bit, but okay. So Mongo is also very fast. A lot of times you're making your application with MySQL, the data starts to get huge, it starts to get kind of overloaded, and you find there's some data that isn't really that important, so you throw memcached in front of it to like take off some of the load. You can do some nice quick updates with that. So a lot of people switch to Mongo at this point. They're starting to get overloaded on MySQL, and they got memcached in front of it, handling some of it. So now they replace it with MongoDB, and then they find out they don't actually need that memcached layer anymore. MongoDB does incredibly fast updates and inserts. By default, it doesn't actually check if an insert or an update succeeded. It just sends it and goes on its way, which is not what you want for like an e-commerce site or something. But it's fine if you're like doing mouse clicks, tracking mouse clicks. And it's cool because even on my like anemic little laptop, it can do like tens of thousands a second. And on my my coworker's like super machine, he can do like hundreds of thousands of updates a second. And so from someone using MySQL where updates are sort of this heavy thing, it does these really nice fast in-place updates that people are using to do this stuff that they could never do before, like these real-time analytic things. Like, so here's some of the people that are using MongoDB for real-time analytics right now. And Chartbeat is a cool one. They got this nice little dashboard. So you can sign up for them. They'll throw every mouse movement, click, everything every user does on your site into Mongo. And you can just throw data as fast as you can into Mongo, and it'll just sit there and be fine with it. So it's nice because you can get, like, see what things are trending, what things are going viral, right as it's happening, and move things around your front page. You know, a lot of analytics sites, it makes you wait a day or a couple hours to aggregate this stuff. So, and then MongoDB is powerful. Most non-relational databases, when they say, oh, I'm being used in production here, I'm being used in production there, they're just being used for this tiny little portion of the application. You know, indexing something, or holding indexes for MySQL, or you know, doing something like that. Mongo is powerful enough to run a web application all its own. It basically almost anything MySQL can do, Mongo can do. And then we tried to make Mongo scalable. So scaling has kind of two sides. There's you get too much data and you need to scale, or you get too many users and you need to scale. So I'll handle data later. But if you're getting too popular, which is a nice problem to have, you need to scale and make it so that they all can have a nice user experience. So you can either make things faster using getting better latency, or you can get more people through, or throughput. So it's basically a difference of getting people there in a fighter plane, everything takes like a millisecond, or getting people there in a jet plane, where you know it might take 50 milliseconds, but you get 100 people or requests there. So backing off from the stupid analogy, so like MySQL, as people know probably here, can scale. People have done it. People have done it very successfully all over the world. It is however difficult. It's hard. Its relational nature makes it so, you know, if you want to relate something with a billion rows to something else with a billion rows, that's not going to be good. So you end up doing some sort of, you know, combining them or something, and then you are losing some of the nice stuff the relational database is going to give you. So it's kind of ugly. You can stretch it, but it's hard to do. And so we kind of broke the relations between any of the objects, any of the records in your database. So you never have to relate them to each other, and it's much easier to distribute. So a lot of people, they run out of room with their MySQL instance. You know, they say, I've got a billion documents, and you know, MySQL is not holding up. And we're like, a billion documents, that's nothing. So they move to Mongo, and they think that they need sharding because that is what they needed when they were on MySQL. And then it turns out that MySQL is just fast enough. It cuts down the latency so much that they don't need the throughput that, like, adding a bunch of servers, sharding, would do. It's just fast enough as it is. So, getting back to the easy thing. So if we take a step back and we look at these relational databases, as pointed out, we got the databases, tables, rows, schema, joins, and transactions. So with Mongo, it's very similar, actually. We've got databases, and then we don't actually have databases containing tables because Mongo is a document-oriented database. It's not a relational database. And forget everything you've ever known what a document is. It's not that kind of document, probably, unless you know about Mongo. Because it's, if you know Perl, it's like a hash. If you know Python, it's a dictionary. If you know PHP, it's an associative array. Java, it extends map. It's basically like a little hash of things. That's what a document is in the MongoDB terminology. So and I mean, like, it would be nice to call that an object-oriented database, but people had already taken that term, so we had to use document. So we also renamed the terminology here a little bit so that people wouldn't get confused. Like a table, it sounds like an Excel spreadsheet, so we called it a collection instead. So databases contain collections. And then instead of rows, you've got documents. So, and then you don't predefine schema. You can throw anything into a collection, any shape, any size. Just have to trust your programmers. And no joins. Everything sits on its own. And then we threw transactions out the window. So you obviously can't have ACID transactions because you don't have transactions. That isn't to say you do have atomic operations. You can do very complex things on a single document at once. You just can't do it across multiple documents. So basically, if we get rid of all the stuff that I crossed out, you've got databases which contain collections which contain documents. And you can just think of collections as tables and documents as rows if that makes you happy. So a lot of people have come up with these nice GUI things to picture Mongo data. This one is Mongo 3, which is one of the most gorgeous ones, and I've heard it's also incredibly hard to use, but it's really pretty. But you know, people have done like PHP myadmin and PHP moadmin. You can guess what that was off of, and all sorts of other ones. So, but one of our users said Mongo comes with the most intuitive user interface in the world, the command line, which is true. We do. When you download it, it comes with a shell. So Mongo is really tightly tied into JavaScript. It's always been really close with JavaScript. When you start up a Mongo server, it starts an instance of SpiderMonkey, which is Mozilla's JavaScript engine. So you can run JavaScript on the server. You can, and then this is a JavaScript shell. It's a full JavaScript shell. You can just execute random JavaScript with it. And it's also tied in. It's connected to this global variable DB to Mongo database, to your database server. So it's connected to this database test. So it starts out connected to this database, and then here you go, SQL people. You change the databases by doing use whatever. we sort of enhanced JavaScript. And like, I know no one likes JavaScript, but everyone knows some. I think that was part of the decision there on using it, because like, you know, Lua is nicer, or, you know, I've heard all sorts of arguments about we should use this or that, and it's true, but like, everyone's had to make some web page in Java at one point, so everyone does know it, and it's not a bad language. So anyway, and then you're connected to the blog database. If you notice here, there's a difference between this and your usual relational database in that you never had to create the blog database. You just start using it. Mongo really cuts down administrative overhead here. You just start using things. You never have to predefine them. So you have to be careful with typos, but it's nice because you don't have to plan quite as much. So then, if you remember, we had the databases which contain collections. You just get a collection by doing dot getter on your database, so you get the post collection, and then you're in the blog database post collection. Again, with no administration. If you do something like a count or a query on this collection, if it's not created yet, Mongo will treat it like an empty collection. As soon as you insert something into it, it'll create the collection and the underlying database if it needs to. So what does a document look like? This is a sample document. You've got basically, like I said, a set of key value pairs. It starts out, you know, title field with string type and the value. And the most interesting one is the comments one, which is an array of objects. So, and then to insert that into Mongo, you can just call insert on the post collection. So this is like roughly equivalent if you're looking at SQL as just an insert statement, insert into the post table these values. The difference in Mongo is that it stores all of the key names and all of the types in for each document, because each document could have different key names and key types. You could keep all of your data in one giant collection, although that's a really bad idea, but you could. So yeah. Okay, and then to query for it, you just again use basically JSON object, a document with the criteria that you're looking for. I'm looking for every document with a title called a post. And so it's same as this SQL, basically just taking the where clause and turning it into JavaScript. So then to find everything, same as just a select without a where, just don't pass it any arguments. So the interesting thing about this thing is it's got the nested field. So if we wanted to find everything with comments by Jim, we could reach into that nested object just using dot notation and query for any fields within the nested things. It's cool because these things are like kind of first-class citizens. You can, you know, query for them, index by them, sort by them. You can do a specific array index too, but if you don't put the array index in, it just looks through every element of the array. So speaking of indexes, Mongo has full indexing support. You can do normal indexes, creates an index on your title field. You can do multi-key indexes. You can do unique indexes. And then this is how you'd index on an inner field. So that would make that query super fast. And then this is just the update syntax. You call update on the collection. And then you pass it the criteria, whatever's in the where, as a JavaScript object. And then a special $ prefixed modifier, $set in this case, matching nicely with SQL, but that sets it to a new value. You have a little more flexibility here because it could set it to any type, any size, null, a megabyte of data, a date, anything you wanted. So we've got all these different types of modifier things that you can use in your updates. The set, and also an unset, you know, for deleting fields. Increment, which is used a lot by the people doing the analytics. Does an in-place update really fast. And then a bunch of array operations. You can just create arrays on the fly in your objects, pushing new elements on, popping elements off either end, pulling elements by criteria. And then there are like dozens more. So in SQL, you can express things really easily with like a normal expression, like that you've seen in algebra when you were in high school. In Mongo, since it's like a JavaScript object hash kind of thing, it's a little more difficult to make it look natural. So you also use these $ things for comparisons. So you can kind of see the mapping there. It's just a little different. But then there are a bunch of these that work for queries as well, greater than, less than, equals. And then you can check like existing and what type the field is and stuff like that. So MongoDB, you can do a lot of the same things as MySQL. These dynamic queries, basically you can do almost everything that you would other than joins using Mongo. So some things that Mongo added that we thought are cool are we did capped collections, which is this type of collection where you set a size on it. And it works like a queue. Once it fills up to whatever size you gave it, it starts throwing out the oldest entries. And then inserting new ones kind of in the front. So that's really nice for people keeping logs, because you may have had the experience of your logs just grow and grow and grow, and no one cares what's way back months and months ago. So I mean, people are like, well, what if you hit the front page of /dot, and you suddenly have another 10 gigs of logs? And okay, yeah, but you have to plan for that. But it's kind of a nice way of minimizing the administrative stuff you have to do, just keeping your collections in check. And then, so storing big files. We felt like this was a problem that was not really handled particularly well by relational databases that are out there. So we took a stab at doing it better. Basically, what you can do is any of the drivers, you pass in like a file name, a file handle, and Mongo has a max size of 4 megs on a single document to mostly prevent bad schema design of people putting an entire collection in a document. So basically, it'll take a file that's larger than 4 megs, and it'll break it up into chunks that are 4 megs or less in size. And then it'll create a unique ID for each of those chunks, for the overall file, and label each of the chunks with that unique ID, and save those all in the database. And then it'll also, you can create a metadata object with any fields you want and that ID, and so you can just access it like a normal document, keep track of downloads or whatever, keep track of user data, anything you want, and then you can just pull it right back out of the database. The driver will reassemble it for you and spit out a full file. Mongo also supports MapReduce. I mean, we figured, with the sharding thing, this way you can just have a job and have it go out to all your shards. You can run them on slaves. Basically, what it is again with the JavaScript, you pass in a JavaScript map function, a JavaScript reduce function, and Mongo runs them with the JavaScript engine. So I never realized that people actually liked stored procedures, but all of a sudden, like whenever you say I've got a NoSQL database, people are like, well, does it do stored procedures? And so yes, it does. Sort of. You can store any JavaScript you want to Mongo and use it from Mongo. So it does store JavaScript that it can use then as sort of a global variable, or global function or global object. So it's kind of flexible and interesting. We actually don't recommend people use it because it's like keeping a chunk of your data out of source, a chunk of your code out of source control. But it could be handy if you got a bunch of teams working in different languages, and you don't want to modify this one JavaScript function in everyone's code if something changes. And then we've got geospatial indexing, which is cool. We're one of the only databases that has this, period. So basically, you saw the ensure index earlier. You ensure geospatial index by just passing it 2D as the argument instead of an integer. And then you can do queries. You insert things by either in some sort of pair form. So either an array of 2 elements or just some object with 2 fields. They can be named whatever you want. And then you can query for things near something or things within a box or within a circle. You can also do more complex queries like find me all the museums near whatever if you have more fields that you wanted, not just location. So and then one thing I glossed over kind of in this whole crossed out thing was the throwing out the transactions. So if you look up on the MySQL documentation, actually, MongoDB has this big warning about using transactions. Because basically, if you do a transaction, you tell the database, okay, insert something, and then the database tells you, okay, it's done. Committed, good job. And then you go on your way. Unfortunately, like some operating systems don't actually listen to the database. They're like, oh yeah, I inserted that, on disk. And they didn't actually do anything. They were buffering to be more efficient. So then if your hard disk is buffering, someone trips over your power cord, then you come back and no one has any idea what you're talking about. So we felt like you can do better than this. If you have a hardware failure, your disk is corrupt or something, a transaction log is not going to help you a whole lot anyway. If you have your server crash and you have a high availability application, are you really going to replay a transaction log for however long it takes? You have to reboot the machine, restart everything, replay the transaction log. So we figured we want to make something with a really good failover system. We didn't focus so much on single server durability because we feel like that's not so much where the future's going. You have a lot of servers, you spread out your risk. So the recommended way of running Mongo is you as a blue man, you talk to your master server, and it replicates data to the slave, which is example 2. We'll put a master hat on the master server so you can keep track. So that's your master, and it's replicating data. And so if that goes away, then you can just fail over and use the slave, and promote the slave to master, and use that instead. And it's also nice because if you have a slave, you can do reads off of it, which is actually what SourceForge does. SourceForge is running entirely on MongoDB. Basically, each page you see is one document in MongoDB. So they have one master and 6 slaves, and so they scale out their reads because it's a very read-heavy application by just using slaves for reads. So they tried it with their current load, and it worked well. So they decided to load test it, and they tried it with 10 times their current load, and it worked well. And they tried it with 100 times their current load, and it still worked fine. So they figured they probably weren't going to go much further than that all of a sudden. So yeah, so 6 servers can handle easily 100 times the load of SourceForge. So that's nice and all, but failover, you promote a slave. Well, at 3 in the morning, you have to get paged to, promote the slave. So we figured, why not just let the machines deal with this? So we came up with this concept of replica pairs. We've got the master server, which is replicating to the slave, and the client is actually connected to both of them, but it's only using the connection to the master. So that way, if the master goes down, the slave is like, I wonder what happened. And it waits a couple seconds, makes sure it's not a network error or something, and then it promotes itself to master. And at that point, the client, who's been a little confused, but all the drivers handle this automatically. You don't have to do anything except catch exceptions. Then the client will see, you are the new master, okay, and just start using that connection instead as the master connection. And then if you bring the old master back online, it will become a slave to the new master. So you can go back and forth. And what we're working on right now is just expanding this to the end server cases. So you can have servers going down all over the place, and it'll just automatically promote the one who's most up to date on the replication. Which brings up the problem of how do you know who has what on the replication? So we made this thing. You can tell it, okay, I want this many slaves to have it before you return a success. So then your server will replicate it to, end slaves, and then it'll return that it's okay. So, and then it'll eventually finish replicating to the rest of the slaves. So if the server goes down and it hasn't returned this success yet, you'll get a big exception. And then when a slave is promoted to master, you can handle the exception and just try it again with the new master. So like, as I mentioned, the replication thing is good for scaling reads. You can just do reads off of these slaves and add as many slaves as you need more reads. But that doesn't really help you scale writes because there's this one server that's handling all of your writes. You will always have just one master. The slaves are read-only. They just have the copies of the data. They can't be written to. So to scale writes, we did sharding. And then you can combine them to get both. So if you've gone to a talk on Mongo before, or I don't know, looked at the web page, you've probably seen a diagram that looks like this, which explains our sharding. So you've got your client, which talks to MongoS. MongoS is a routing program that just routes out requests. Your data is divided up across the shards, which are blue. Each shard has like just a section of like end of time, or beginning of time through March 7th, March 8th through March 12th, March 13th through infinity. So it just splits up your data according to some key that you give it. And then there's a configuration servers on the side, which keep track of what's on the shards and redistribute data. And it's all very confusing and not a very good diagram. But it's pretty simple. It basically works like the American Mafia, or how the Godfather taught me that the American Mafia works. So basically you got the shards, which are the peons. They do the actual work. Then you've got the Godfather, who knows what each peon can do, and just gives the orders. Then you got the config server, who's basically the conciliary. He is the brains behind the operation. He takes care of figuring out who should go where, who should take care, like if you're getting unbalanced, he'll redistribute the load. He takes care of everything behind the scenes and lets the Godfather know what's up. So basically, if you do a query on this, you query the MongoS exactly the same. It's completely transparent as to how it works. There's no difference between querying MongoS and querying a normal MongoD. So it's not like you have to upgrade your application to use sharding. You can just start using it when you need it. So you basically send a query to the MongoS. The MongoS knows what data each shard has. It's basically just like a table of contents. So it says, okay, these two servers have that data, so it sends the query to them. They actually execute the query. They send back the data that you want, whatever the query results were. The MongoS aggregates it, and then sends it back to the client. If you're doing an insert, similarly, it knows kind of the ranges for each shard, so it knows which shard to send the insert to. Sends it, the insert gets processed. So the conciliary, what does it do? So if you end up with a shard that's getting unbalanced, the conciliary's job is to redistribute that. It locks down the shard, it splits the data, and it migrates some of it to a different shard. It also, and then after it's finished doing that, it updates the boss on what the new configuration is so the boss can continue routing requests correctly. So it also takes care of if you add a new shard. It might decide, okay, everyone looks pretty balanced, we don't even need this yet, and just know that it's there for later. If someone is looking a little bloated, it will then just have it split, migrate to the new guy, let the boss know about it. So in these examples, it looks like one shard each, but really each of these, every shard could be a replica set. You can have as many MongoS's as you want, and config servers. We really tried hard not to make any single point of failure. And these can overlap on boxes too. You don't have to have one box for every single one of these processes. So we really want to have a really sturdy production system. And by the way, this is all in alpha. And we're trying to get it to be production ready in 2 months. So everyone's doing this huge push now. We're in the middle of it, getting it production ready. But it's a little rough around the edges at the moment. Not at the moment. It's just everything that can happen automatically does. We might add more tuning things after we have it more production ready. Yeah, and it would make sense if people have like a super server for one of their shards and like a really crappy commodity hardware server for another one to be able to do that. But, yeah. So if you guys thought any of this was interesting, I encourage you to go to try.mongodb.org, which has a little mini browser in your shell, and you can type tutorial, and it'll bring you through like a little tutorial on starting out using Mongo. Or you can just download the database. And then also we're having a conference, Mongo SF, which unfortunately is actually sold out as of like 2 days ago. But we're still looking for like video audio people. So if you want a free ticket, that is an opportunity. Oh, sweet. Okay. Never mind. You don't get to come. Yeah. I encourage everyone to try it out, download it. If you have any questions, the user group is really, really active, so feel free to send a message or whatever. Thank you. Okay. I think someone actually did one. I saw something on Twitter about someone doing a cacti thing for Mongo, but I didn't really look into it. But yeah, I mean, we've got replication stats in the shell. The shell is really the primary admin tool. You can see how far behind a slave is, and it's like db.replinfo or something. I don't know. It's like more of a JavaScript function than a SQL statement. We kind of mimed a few of the SQL statements, like the use, whatever, but most of the stuff is just JavaScript functions. Yeah. And apparently we just pushed something that typically slaves will only run a few milliseconds behind, theoretically, but before it was seconds. And, it's hard. Some people had problems, if they're doing big map-reduced jobs or something, things would get behind. But. No, that was a bad example in that way, but yeah, we're very type-rich, all the basic types, null, bool, date, int, binaries, code objects that are like JavaScript. Yeah. So. Yes. Well, it doesn't actually do sum, but you can do that with a group or MapReduce or something. No, it doesn't. No. You can't do auto increment because it doesn't distribute very well. And it's always been focused on. Excuse me. Oh, well, Mongo has its own auto-generated unique ID, which is based on like timestamp, machine ID, process ID, and an incrementing number that's just generated by the client. So it's very high probability, very high probability that it'll be unique across multiple servers with no interaction between them. Oh, it's actually generated on the client before it sends anything to the database. All the drivers take care of generating the unique IDs. So. No, it's actually 4 bytes shorter. Yeah. Yeah. Yes, quite a few. It's nice because you can take like a snapshot of your whole file system and just. I'm not terribly familiar with it. I don't know. Lots of RAM. I mean, to get the memcached-like performance, you need your indexes in RAM, or at least your working set of indexes in RAM. So it does a least recently used thing of getting indexes out of RAM. So if you're using your if you're doing random access, the performance will suffer. If you've got like some subset of your data that you're accessing, like current data, kind of moving up in time, then it'll work really well. So. Oh yeah. Yeah, you can do bulk insert either just through a driver, or we also have import, export, dump, restore tools and stuff. Yeah, you can take a dump and then restore it.
Does stuff happen offline, online? Not go offline and take a dump?
Yeah, you can, we have this thing where you can do an fsync lock, and then you can take a dump, and then, you are terribly immature, and then, and then you can unlock it and go back, and you can just do, yes, or you could just do it on a slave. That's what we recommend, is you just set up a slave, lock it.
But it has the ability to do.
Yeah. Yeah. Oh. So I think on like a normal PC, for updates, inserts, removes, you'd have like 30. Actually, for key value queries too, is like 40,000 a second or something. So it's yeah. Like 4 gigs maybe. I don't know. Well, it generally depends on the driver. Like, I think in Java it's like an array of bytes. For PHP, I just define my own class called MongoBinData, and you pass it binary data, and it serializes it as just basically the binary data and says it's good data. Mongo's typed itself. It's got like 16 types, I think, or something. Like file system snapshots, or yeah, it was like what we were talking about here is you take a slave, you lock it, you do a dump on it, you unlock it. Yeah. You can also, shut down the database and, copy the files or something, but that's a pain. Yeah. You wouldn't want to do that. Yeah. So. Oh, no, it's fine to run it with application servers. I think most people start out that way. So, I mean, if you create a collection and then you add a new index to it, that's a fairly intensive operation. If it's a big collection, it's going to take a while and take a lot of resources. It can be done in the background, but, you probably want to do it in an off hour. I believe so. I think so, because you can do it in the background, so I think whatever you wrote would just be indexed. So, I don't know, there's not, it's probably, like, you can't always do it, but it's good to set your indexes before and then insert your data. Yeah, no, definitely. Like people have to change their indexes and whatever, but just do it in an off hour. It can handle writes while it does it, but yes. Yeah, we've got explain. You can run on any query. You can set a profiling thing to spit out information about all queries, queries that run for longer than 10 milliseconds or something, and then no queries. Oh, no, like, basically everything is sort of its own atomic little thing, collection. You can't, like, do any sort of join thing. Yeah, like, I mean, you could do just 2 queries, you know, query for a user and then query for all their comments or something if you're keeping them in separate collections. Really, we try to have people do the nesting thing to some extent. And then if you have like a real many-to-many relationship, you might just have to do 2 queries. Well, I mean, initially, if you're moving from just a single server setup to a sharding thing, you have to change something because, you know, you got just your server listening on this port, and you've got your application configured to connect to that port. And then you have to start a MongoS and have your application connect to MongoS instead. Okay. Oh, you send a command to the MongoS server telling it, I added this address node, and then it takes care of all the deciding whether to move data or not, or when to move data. Yes. It should be. Yeah, and I mean, you can add more MongoS's if you wanted to, if that's your problem, which it shouldn't be, but like, theoretically you can saturate that. I suppose. It hasn't really come up because no one even needs sharding yet, but like, it's, like, I'd imagine eventually it will. 12 terabytes. I heard someone say 40 billion, but I'm not sure if that was true or not. No, I don't think so. I don't know. Maybe they're playing with sharding. I don't know. We are thinking about doing that at some point. We actually might. Yeah, we actually implemented 2-phase commit on maybe the config servers already. So, yeah. Yeah, like a lot of people start out with logging because it's got the nice insert performance and it's nice having the scheme-free log. And obviously the analytics are a big application people have found. A lot of people are using it for the data file storage. Apparently the geospatial indexing is a little faster and more accurate than Postgres's, which is the only other one I know about. So people have started moving into that. What else? I don't know if you've heard of like Discus doing the comments blogs you sometimes see. They're running on Mongo. So a lot of kind of social networking, Web 2.0 things. You can run it with authentication. It's very coarse-grained at the moment. It's just like for database authentication, and then you have any permissions in that database if you're a user for it. So, I mean, that's what, there's a couple shared hosting kind of things that are running Mongo, and that's what they do. But, Yeah.
So can I apply it
Well, Mongo kind of defends pretty well against that as far as someone on the outside doing an injection attack, because we don't use SQL. We use this format where you'd have to be a complete moron and do like an eval in your JavaScript to. Yeah, I mean, like you could, you totally could, but you can like pass in the scope and stuff, so you really don't need to. So like basically, if you're using MongoDB, even like you could be almost a complete bonehead and use MongoDB, and there's no kind of security injection-y kind of things that someone could do, because every object has a given size, and you know Mongo's not going to just randomly execute things. If you have a what go down? Oh, yeah. Yeah, if the config servers go down, the sharding will still work, except it won't have the auto rebalance and stuff. Yep. I don't really know much about that stuff. If you go on the mailing list, a couple of people have asked that sort of question. I don't think we support that yet. Oh, okay.
You can see the raffle.